E. coli is great at producing lots of DNA through replication. Once we have a culture of transformed cells, we often need to extract the plasmid so that we can actually use it. This could include storing it for future transfection, such as into mammalian, yeast, or plant cells, or to sequence our plasmid to confirm it's correct. We always check our nanodrop values after mini-preps. It can be stressful because it's like judgment time of your mini-prep abilities. To make it less stressful, we're going to go through a mini-prep and see what steps we can take to make sure that we get high purity and high concentration after the end of our mini-prep. First, we take our overnight culture and we cryopreserve. This is important because if we use all of the cells, we can't regrow the exact same colony of E. coli to produce more plasmid. This could be crucial if our mini-prep results are bad or we run out of the plasmid and need more. Now we centrifuge to pellet the cells. Make sure the centrifuge is balanced so that you do not damage it. We ideally want to use the most cells that the mini-prep is designed to work for, since this means we will purify more plasmid. However, using too many cells is an issue because the lysis buffer will not lyse all the cells and we will end up with a bubbly pellet of cell waste. Also, remember if you're doing multiple mini-preps at the same time to label your microcentrifuge tubes. From here, we start the mini-prep. The exact buffers vary from each company's kits, but the general idea is the same. We lyse the cells to release the plasmid, neutralize, remove the plasmid containing supernatant from the cell waste pellet, and wash to remove any other contaminants. Each step has its challenges that can affect yield, or at worst, you can accidentally wash your DNA away. Now, we will take our pelleted cells, discard the culture medium, and resuspend in the resuspension buffer. This might include RNase A, so make sure this buffer is kept at 4C, since RNase A is an enzyme. If the enzyme becomes inactivated due to improper storage, the RNA won't be removed. Now we will open the cells with lysis buffer. For the next two steps, we have to be careful. If we shake too hard, we will destroy the plasmid DNA or open the nucleus, which causes our sample of plasmid DNA to be contaminated with genomic DNA. We often have to incubate for 1 to 2 minutes at this step, but don't let lysis continue for too long. We might destroy the plasmid DNA, and this can also cause genomic DNA contamination. Now we will add the neutralization buffer and carefully invert to mix for this step. The cell waste becomes a visible precipitate. Be patient and invert until the color fully changes. Now we will centrifuge again, and this time the pellet is waste, so be sure to not pour away the supernatant because it contains the plasmid DNA. Carefully move the supernatant to a column, avoiding the pellet because the goal of the mini-prep is to separate the cell waste from the plasmid DNA. Now that we have the plasmid DNA in the supernatant, it is time to wash it to clean other contaminants that were in the solution, like salts. For wash 1 and wash 2, we are introducing solutions to clean contaminants while our plasmid is bound to the column. Make sure to not touch the column with the pipette because you might scratch or remove the plasmid. Also, make sure to read the instructions on your reagents before use and add ethanol or other solutions as instructed. Often you need to add ethanol for wash 2, and if you don't add it, you will wash your DNA when you use this. Also, if the flow-through makes contact with the bottom of the column, the contaminants will touch the DNA. So make sure that you empty the waste in your collection tube and spin again if you think that the column is still wet. Finally, we can elute our plasmid. Be sure to move the column into a new, clean microfuge tube. If we elute into the contaminated collection tube, all of our purifying efforts will go to waste. There are several recommendations to increase yield on this step. You could incubate with elution buffer longer, or you could heat the elution buffer to 50°C. You could try these, but just make sure that the elution buffer touches the column matrix without touching the column directly with the pipette. Finally, we can check our mini-prep results with a nanodrop. We're aiming for a A280-260 of 1.8 to 1.9 and an A260 over A230 of 2 or higher. Having followed our protocol really carefully, we get good values, ideally. And if not, you should work through this protocol to see what could be the cause of your low purity and try to optimize to improve your results.